Welcome, pilot, to another Starfighter Inc. approved training video. We introduce more advanced piloting skills and maneuvering tactics that will enhance your practical warfighting abilities, increase your combat effectiveness, and improve your bottom line. We recommend that you complete the basic flight and combat tutorials first so that you will get the maximum benefit from what you will learn here. Topics covered in this program include the essential PVI indicators you need to maximize situational awareness, the optimal use of RCS thrusters and main engines to maximize maneuverability, the flip and burn maneuver, duck and cover tactics for close quarters combat in constrained environments, missile evasion maneuvers and CIWS tactics, the optimal use of the Shrike's advanced sensor suite, and using repair stations to restock weapons and propellant. Situational awareness is about knowing what is going on around you. Where are my friends and how are they doing? Where are my objectives and can I complete them? Where's the opposition and what are they doing? Is there anyone or anything else I need to worry about? The better you are able to maintain continuous awareness of your own position and status relevant to everything else in the battle space, the greater your ability to project their future status, recognize threats and opportunities, and outthink your opponents.
Form on me, and we'll attack together.
Building on what you've already learned about the Pilot Vehicle Interface, or PVI, in basic flight training, the next most important indicators are the throttle and RCS indicators, which give you the status of your ship's thrusters, the RDAMP and TDAMP indicators telling you how your ship's flight controls are going to behave, and the prograde and retrograde markers, which help you orient yourself regarding your ship's attitude and actual direction of motion. The throttle indicator shows how much thrust is being applied through the main engine or engines. RCS stands for Reaction Control System. This indicator simply tells whether your ship's maneuvering thrusters are working properly. The RDAMP, or the rotational damping indicator, shows whether this pilot assist feature is engaged or not. By default, it is turned on and uses your maneuvering thrusters to automatically slow and stop any roll maneuvers. If disengaged, your ship will rotate freely and not stop, unless you apply the appropriate counter thrust either manually or by toggling the RDAMP back on. Do this by pressing X on your keyboard. Most pilots prefer to keep RDAMP on most of the time. The TDAMP, or the translational damping indicator, shows whether this pilot assist feature is engaged or not. Toggle it by pressing Z on your keyboard. By default, it is turned on and uses your maneuvering thrusters to automatically adjust your ship's movement vector to align with its heading. The result is to make the ship fly in the direction you point it. This is very helpful when flying in a constrained environment or executing docking maneuvers. If disengaged, you may adjust your ship's attitude completely independent of its movement vector. This is very useful in combat when you wish to bring weapons or sensors to bear on off-axis targets, such as when executing a strafing attack.
You are targeted. You are targeted.
Do note that using RDAMP and TDAMP comes at a cost. Both systems use up propellant, especially the TDAMP. This is why most pilots turn the TDAMP off, except when entering a hangar or repair bay. Remember, turning the TDAMP off allows for greater maneuverability and more economical use of propellant. Since there is no friction in space and your ship can be pointed in a direction other than the way it is moving, the prograde and retrograde indicators help you orient yourself by telling you which direction your ship is moving toward and away from, respectively. The prograde vector is indicated with a free-floating icon, highlighted here, showing the direction your ship is currently moving in. If you cannot see it because you have pointed your ship away from its current movement vector, look for the triangle icon with a plus sign in it. This always points towards the prograde vector, even when it is out of direct view. Simply steer your ship or look in the direction indicated until you find the indicator. The retrograde vector, also indicated with a free-floating icon, highlighted here, is always at 180 degrees opposite of your prograde vector. The half-circle dash icon indicates the direction of your retrograde vector. This is useful to look for when attempting a flip and burn, but you will need to disengage the TDAMP first. Unlike the aircraft back on Earth, spacecraft have complete freedom of movement in any direction and can better exploit the three-dimensional environment of space to their advantage. As noted previously, the ability to orient a ship independent of its movement vector allows its weapons and sensors to be employed against a target without forcing the pilot to fly directly at the target.
Target targeted.
For ships with conventional tail-mounted main thrusters, the flip and burn is a quick maneuver you may employ to decelerate your ship as quickly as possible. The concept is very simple and straightforward, but the technique does take some practice to use effectively. Assuming that you were already facing the prograde vector, disengage the T-damp and flip the ship around 180 degrees to face the retrograde vector. Now apply full thrust as long as necessary to slow the ship to the desired velocity. Do note that if you continue to apply thrust, your ship will eventually start moving back in the direction you came from, and the prograde and retrograde indicators will swap positions.
Flight system.
The same logic used in a flip and burn can be applied to flying in tight spaces with little room to maneuver. Combat quickly becomes hectic, and a hasty redeployment may be needed. Quickly accelerating to a point of safety and then being able to get around it for refuge is an important skill to learn for a longer life expectancy. Similar to the flip and burn, this maneuver is called the duck and cover. As you maneuver your ship's main engines to be facing the object you are trying to avoid and going full burn, instead of using your ship's RCS thrusters to make the turn, you are maximizing your thrust by utilizing the ship's engines to pull off what would otherwise be an unfortunate end to company assets. In addition to using main engines to take tighter turns, some ships have RCS thrusters in certain spots than other spacecraft. Knowing where these are located can help an experienced pilot harness the maximum maneuvering their craft has to offer.
Capturing.
It is worth noting that this maneuver is more effective if used to miss an incoming object, rather than stopping all momentum and changing course.
You are targeted.
Missiles can be a devastating weapon when employed properly. However, they can be spoofed or outmaneuvered depending on the class of missile, or destroyed outright with rapid-fire close-in weapon systems. The most important thing to pay attention to is your threat indicator. This system will blare an alarm when it detects a missile has been launched at you.
Are targeted.
Most missiles fly a direct path to intercept their target. If you were already flying away from the missile and it was launched at long range, you may attempt to outrun it, but this is very risky. In any other circumstance, this tactic will usually fail, but there are other methods. If the battle space contains structures or terrain that offers cover, then use this to your advantage by flying behind the cover and fooling the missile into destroying itself against it. Note that this is not recommended when your mission is to protect the object you are using for cover.
Target locked.
Sometimes the most effective tactic is to fly towards the enemy missile. This is because if your ship has a high enough relative velocity, you may be able to get inside the missile's maneuver envelope. This can be achieved thanks to the insane acceleration and velocity of the missiles themselves, which makes it more difficult for them to change direction quickly. The key is knowing the right moment to slightly change course in any direction that can cause the missile to overshoot. This will force the missile to deplete its limited propellant, leaving it without enough delta V left to reacquire you. While this is an effective tactic, it can be quite costly in propellant, particularly if you were not already heading towards the missile at high speed to begin with.
You are targeted.
Close-in weapon systems, or CIWS, are the most common countermeasure used to defeat enemy missiles. Most combat spacecraft have at least one gimbaled or turreted laser or high rate of fire cannon that is capable of automatically responding to incoming threats. The CIWS mode must be enabled, of course, and this allows the pilot to focus on their mission objectives while trusting the CIWS to eliminate the enemy missile.
Are targeted.
Once an incoming missile is detected, the system locks on and tracks the target, opening fire as soon as it is within range. Experienced pilots never completely trust automated systems and will hedge their bets by using some standard maneuvers to improve the effectiveness of their CIWS. Simply flying away from an incoming missile increases the amount of time your weapons have to fire and increases the odds of a successful intercept.
You
Note that CIWS effectiveness is greatly enhanced when flying in formation with allies whose additional CIWS increases the coverage and hit probability.
Weapon disabled. Sensors activated.
When switched to active mode, the sensors on a Shrike expand from the main hull to boost their effectiveness in gathering information about the battle space. The Shrike Sensors also send out a pulse highlighting nearby objects. These sensors are especially useful in tight, dimly lit locations where a wrong turn or poor management of acceleration can end poorly for the Shrike. While active sensors provide very useful capabilities, they greatly expand the ship's profile, making it a bigger target. The sensor panels are also more vulnerable in this configuration, and can easily be damaged by enemy fire.
Destroyed.
Modern combat spacecraft are often designed to be extremely resilient and even capable of repairing themselves to some extent. From self-healing propellant tanks to multiple redundant sensor systems distributed throughout the space frame, most fighters can absorb a surprising amount of damage and remain effective. When the damage exceeds the ship's internal capability, you will need to find a repair station. Repair stations are automated facilities usually found within or near the station or mothership from which you deploy. And while they are almost always referred to as repair stations, they can also replenish your weapons and restock your propellant tanks. Fortunately, the process is very simple and very fast. When needed, pilot your ship over to the blue highlighted box shown on your MFD. Enter the box at a low velocity and slow down to less than 2 meters a second once inside. This will allow the automated systems to get your ship back to 100% combat effectiveness in just a few moments. Depending on the terms of the contract, some or all of the cost of repairs and replenishment will be deducted from your earnings after a mission. Inexperienced pilots are often shocked by how expensive it is to visit the repair station multiple times during a single engagement. Nothing sours a clean victory quite so much as a zero-credit earnings statement. Congratulations on completing this instructional video. We hope you found it valuable and urge you to follow the entire series. Here at Starfighter Inc., we believe knowledge is power, and the best combat pilots are always seeking to improve their knowledge. But now, you must apply your new knowledge to improve your situational awareness. You must practice the new piloting skills and tactics to improve your combat effectiveness. Ultimately, our bottom line depends on your bottom line. We all benefit by ensuring that you are the best trained, most efficient, and deadliest warfighting assets ever committed to battle. Per aspera ad astra.